so we are going to kind of splice our way through this review, going through parts back and forth. So if we do something here at the start with the first few problems, there will be a part later in the video that also will come back and hit on them again, or you could just pause and rewind me. Either would work well. But we're getting ready for our next quiz here. We've got lots of stuff we've done. So we're going to start here with just talking a little bit about the shifts or the transformations that occur in these radical expressions. So let's just try and jump in. We'll see if we can go this way. So, excuse me, if we start with number 2, what directions are the 2 shifts that I've got working here?
The number that's inside is that going up or down or left or right?
Oh, good question. Okay. Inside is always left and right. Outside is always up and down.
Okay.
So what are they going to be? Left 6. And up 1. Now, just in general, when we're looking at these, because we've seen that before, inside is my left and right, but it's the opposite of what I would think. And then on the outside is my up and down. And that, for the most part, is going to be true in most of the things that we graph. Because that may come up again here in a little bit with H and K. You never know. So that's all we're really looking at with these. Nothing to graph, nothing to solve. No tables to make, just what directions are the shifts, and off we go. So, not a bad start.
So all we have to do is say, for example, number 2 is left 6 off 1, so it's all good.
That's it. All right. Now, we're going to take it a step further in the next part. So when I get up to the next part here, okay, identify the domain and range of each, then sketch the graph. Now, I know it does not say we have to write down a shift. I think it's a really good idea, though. So we're going to. So, what direction is this -1 telling me to go? Down 1. Okay, that could come in handy. So, there's a couple of ways we can tackle this. One of the ways that we've talked about is making ourselves our little chart. And if we've worked with this and remember our perfect squares, 0, 1, 4, and 9, we can just use those. I'm not even going to need to play with a calculator or anything else. And so if I take the square root of each of those numbers, that would be my y. Okay, those would be my parent points, my base points. And so if you've been doing it this way, this is where you would plot those points. We wouldn't connect them, though. There's not a number in front of our x. We're going to deal with one of those here momentarily. So all I would do is I would take each of those points, and I would move them down 1 and connect the dots. Now, we spoke about before, I don't have to do it that way. If I want to, I can pull out a calculator, type this in. Again, the square root is second and x squared. The only thing I really have to be careful of here is being careful that that -1 is outside the radical. If I just keep typing -1 right now, you notice it's still under. That's not going to be good. So I hit my right arrow, type in my -1. I can look at the graph if I want to. It's shifted down some. But the big thing is looking at the chart. And I notice the whole number points are 0, -1 right there. 1, 0. 4, 1. And 9, 2. So you can just use the chart and just make what in this case is my green line and just call it a day. Not going to be wrong. That's fine. I don't care. So whichever one works for you, I am happy to have you work with. Okay? But we still need to do domain and range, so don't forget about that. So domain and range. Domain, my x values from left to right. Here's my furthest point left. starts at 0 and goes forever to the right. My range, my y values. Same point, but now it's the y value I'm looking at, which is down 1 or negative 1.
And then would it be then up?
It would. And as we've spoken about before, there's some little hints in here with domain and range. If nothing ever moved, my domain and range would both be 0 to infinity. My domain moves when I move left or right. I didn't move left or right. My domain didn't move. My range only moves if I move up or down. I moved down 1. So did my range. And even if you're looking for a little bit of a hint, if you're the calculator type, once you get past the error messages, those first x and y values are the values you're going to use with your domain and range. So there's all these tools and little helps available if we just use them. Now, we are going to look at another one of these. Well, actually, I'm going to do number 7. I have a method to my madness here today. I have specifically worked some of these out for us to be able to look at. And so I look at number 7 and I go, okay, first things first. What's my one shift going to be?
Up 1.
Getting closer. Right 1. Because again, inside the absolute value, it's kind of the opposite of what we would think. We normally would think negative is left. But here, it ends up being right. So, if I'm a chart person, same 4 values, my perfect squares. I take the square root of each of those. But this time, we have a little change. Because this time, I have a value in front of my radical. That value is going to change the value of my y's. So we're going to take each of our y's we already have, and we're going to multiply them by 3. And those are going to be my new parent points, my new base points. Now I know some of these get a little bit tricky to get on the page because they're going a little bit off here, but just kind of work with it as best you can. And if you go parent pointing like we did here, now I'm just going to move them all right 1, or shift. And get my graph drawn in. So now here, if I've done everything on my own already and I go to do domain and range, just remember again, that first point's going to tell us a lot. This is my furthest point left. I'm at positive 1. No coincidence, I moved right 1 and my domain moved. Now, did I move up or down at all? No. So my range didn't move from 0. And just to see again, if I'm a calculator person, this time everything is under the radical, so I don't need to use my right arrow at all. I pull up my chart. Okay, for domain and range purposes, there's my 1 and my 0. But if I was just doing my graph with this, again, let's see if the points match up. 1, 0, 2, 3, 5, 6, and a little off the page here at 10, 9. It's perfectly fine to do that. So that kind of lets us look at our square roots, but there's one more. There's one more type we've played with. And for our purposes here this period, it's going to be number 9. You're like, what's so different about number 9? Well, let's take a peek. Yeah, it's cubed now. So first, what's my shift going to be? Close. Up 4, because it's outside the radical. I like the opposite thinking on that, though. That's good. Now here, if I'm a charter, the numbers have just changed. As we were just told, this is a cube now. So we would use our perfect cubes, which is basically 0, 1, and 8, but I can also use negatives. And again, if this hasn't been your style so far, if you're a calculator person, we are going to get to that here momentarily. We like to use all the tools in here. But if I went that route, I have no number in front. I don't have to worry about that. And now I'm just going to shift each of those up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And make my kind of S-shaped curve there with arrows on both ends. Which is cool because, as we mentioned before, these are the easiest problems, or at least should be on the quiz, because I don't have to think on my domain and range. They go forever to the left and right. They go forever down and up. And that's true no matter what shifts you have. Cubed roots, don't have to think. But you're like, okay, you said that if I was not a charter, you would hook me up, and I will. Okay, reminder, when we're doing these in the calculator with cubes, the easiest way to play with them is to take whatever's under the radical, put it in parentheses, and take it to the 1/3. So if you're going that route, this is how I would have you get it typed in. It's just easier than all the button presses to play with moving things around here. And again, we don't have a specific fraction button. We just use the divide button. But here again, I still have to be a little bit careful when I'm typing because that +4 isn't supposed to be up in the exponent. So I do need to hit the right arrow to bring it back down. Because +4 definitely not an exponent. And so here, I look at my graph. Now, for those of us that have graphed already, we see it's looking really similar to the one that we graphed. It's shifted up. But this time, when I look at the chart, holy moly, there's like a bajillion numbers. There's no errors. Still, just use the whole number ones. Okay, -8, 2. -1, 3. 0, 4. 1, 5. And 8, 6. Okay? Still works just like the square roots did. You can absolutely pull them out of the chart and make this work. Yes, sir?
How do you determine the x value? Like, for instance, for number 7, you use 0, 1, 4, 9.
Sure.
Is that every time?
Okay, let me show you what the difference is with those. Let me pull this down so we got them both in here. The difference here is going to be square roots use perfect squares. So 0 works for everything, but then 1, 4, 9. That's how I pick these, is that they're all perfect squares. When I get down here and we're doing cubed roots, now I'm using perfect cubes instead. So 0 still works, but then the 1 and the 8 is where those are coming from. In cubes, you can also use negatives. Excellent question. Glad you brought that up so we can kind of see. So yeah, if you're a charter, that's why we're using those.
Would we be able to use that sheet for tests?
I don't mind putting up, if I did something or put that up somewhere, it probably would be me saying, hey, here's the start of your x values, sort of like what I'm doing there. So like I'll put up 0, 1, 4, 9 and those, and then you'd have to build the chart from there. But yeah, if you want to do that, I think I can make that work. All right, let's see here. What else have I got here to play with? I'll come back to these in a minute. I just want to make sure that we're hitting upon everything here as we go. So if we need to do some more of those, we can. Okay. Harty error. This does happen every once in a while. Use the information provided to write the standard form equation of a circle. Look at, and Harty used the wrong numbers. Wrong numbers. I should have written 17 to 20 for form help. So some of you, because I'm not writing this up anywhere, this formula, you're going to have to be able to come up with it. But here's kind of my, and the quiz itself will be set up the same way. if you peek ahead to the next part, okay, this is the form we're working for. So you've got kind of an outline of what this is going to look like at the end. Here's the one thing we got to remember. When we're making our equation here, because you'll have this part basically from the form. When we're doing these, it's x opposite of h. So whatever you see in the parentheses, you're using the opposite signs. Y opposite of k, opposite of negative 16 is positive 16. And then we square whatever the radius number is, and that's it. Okay? But by some means, you've kind of got to have an idea of that in your head. Yeah, the radius, no matter what's always going to come out positive, just because, yeah, there's going to be no flipping with the radius ever. Nope. No radius flipping. And so, as we peek at these, I'm trying to see if I've got... Let's do one more. Yeah. Let's do the next one here. So just kind of running ourselves through here. So x opposite of h, change my sign, squared plus y opposite of k squared equals, now again with my radius squared. This is just taking 7 times itself. It's not 7 times 2, okay? If you need to, put the 7 squared in the calculator to help remind you of where you're heading with that one. So I just want to make sure that we're feeling comfy with that. Okay? So that's all that is, though. Nothing to solve. Just plug it in and go. So now we're actually going to use the form we're talking about here in the next section. To also answer one other question, which I'm sure is going to pop into your heads if it hasn't already, is the quiz this long? No. It's just I do this so we have plenty to play with and practice with it. So, okay, 17. Identify the center and radius of each. Sketch the graph. My center is found, again, remember, these are opposites of what the actual center values are. So switch the value on your 3. Switch the value on your -1. And this number is the radius squared. So that is not my radius. I need to take the square root of it. So once I've done that, now I go back, I plot my center, coordinate at -3, 1. And when we've done our circle stuff, we've just said that radius, we're going to go 3 each direction now. So we're going to go up 3, right 3, down 3, left 3. Not making a diamond. We're going to do our best here. Put some curve into this. And that's what we're looking for. Switch the signs of your x and y's. Take the square root of the equals number, and then we're just kind of doing a little bit of sketchy with it.
So the numbers in the parentheses, we take the opposite.
Correct. That will get you set with your center. Then we square root that, and we're good to go. All right, let's see what else we got to play with. Oh, review time. Graph the equation, tell me the vertex. Okay. Things to remember again. The shifts are the same as the ones we saw earlier when we were talking about when we were doing the radicals. Left, right, up, down. Same thing going on here. So, a couple ways we can tackle this. Just out of curiosity, what are the shifts? Okay, so if I wanted to go the shift route, it would be right 2 and up 4. Now, what that would tell me is that's going to tell me where my vertex is. I went right 2. I went up 4. So I can kind of see when I'm doing this, because remember, my vertex is just HK. So it's the opposite of that. And then if there's a number out here, that goes with it. So 2, 4 in this case. But I could also do it with my shifts. Lots of good choices. Here, my A value in front is 1. Now remember, A values tell us if our V is going to open up or down. So this one's going to open up because it's positive. And that 1 is my slope, air quote, slope. So I go up and over 1 in each direction. And that's my graph. So graph, vertex, good. And so what I also wanted to take a peek at was one with a little more interest here. So we're going to take a peek at 23. Yes, 23. So 23, I look at that and I go, okay, my vertex is the opposite of H, any K value. Okay. If there wasn't a value in one of those places, we'd use 0. So -2, 3. This time is a -3, which means we're going to be opening down. So I know my V is going to be down. But it also means my little air quote slope down 3 and over 1 in each direction. And I've got everything I need. I mean, there's clues, and I keep saying that over and over, but it's true. We've got to keep getting those clues in here. Okay? Negative opens down, positive opens up, and so on. So, let's see. We've got one last piece to play with here. Solve the system by graphing. Now, with these, we've talked about stuff before. You absolutely can use the calculator table just like we've done on other ones. Don't care. That's fine. If you want to go to the calculator, you also can. So I'm going to show you both. So I'm going to start doing this like we typically would. Just using our base graphs and shifting them around and stuff. So the easiest one of these two is the second one. Y equals 2 is just a horizontal line along that Y value. Okay? That one I can do whether I got the calculator or not. For Y1, if I was graphing Y minus 3, normally I'd make my chart. It's a square root, so I'd use my squares. And since there's no number out here in front, cool, those would be my parent points. So, but I notice there is a shift of right 3. So I would take those parent points, right 3, and connect the dots, and I would notice there's where they overlap. Okay? And where they overlap the x value, there is the answer. Okay? So no calculator, that's how I would tackle this. Now, most of the time we were doing this, we were using the calculator, again, which is fine. But I do, whether I'm using the calculator or not, I still need to graph these. So you're like, well, I'm just going to look on the chart like we were doing before. Not quite so much. Okay? So here, if I go to the calculator for my solution, calculator turning it on is usually a good start. So my y of 1, x minus 3, all under the radical, My y of 2 is 2. That's why we labeled them. I could look at the picture, and I do see that they do cross down here. Looks like about 1, 2, 3, 4, 5, 6, 7. Again, I'm pretending I don't know the answer already. And so I start scrolling down until I see the same y value, 2 and 2. And the x value is my answer. Now again, if that's the way you go to get the x, that's cool. But, oh, there's always got to be a but to everything. But, make sure again that you're graphing your equation. So with the y, you see all the 2's. So to make this line. And again, for your radical, there's 3, 0. There's 4, 1. There's 7, 2. And I can make my graph. You have to graph. Okay? So, I'm going to go on pause because this is going to be the end of part 1.